All right. So this is the second part of our big intro to Python day. And in part one, we covered a lot of fundamentals through primitive data types, complex data types, lists and tuples. We dove pretty deep into functions. We learned about star args and star quargs. We looked at conditional logic for if and else, a little bit about truthiness, all the wonderful ways to loop in Python. And now in part two, we're going to look at list comprehensions, which is sort of a powerful looping tool. What's called a switch case or a match, which is more conditional logic. Lambda functions, which are similar to JavaScript arrow functions, and which will be really important for Python unit tests. We'll see the map and filter functions that relate to lambdas. We'll see how to handle errors with try and except. We're going to see how to import from other files and what a Python module is with some exporting and importing. And we'll also do a little bit of working with files and the file system. There's going to be a couple other things thrown in the mix here. There are some sort of like utility functions, like we're going to look at something called zip, which is very cool. That sort of ties into lambdas and map and filter. And that will be part two. And then kind of the final part of this big series of introduction to Python stuff, we'll be looking at testing, right? And this will use all these other things because we'll be working with files and the file system and modules. We'll install PyTest, we'll set up our first test, and we'll see some cool testing patterns with this tool called Monkey Patch. But right now, we're going to just dive deeper into Python. So let's talk about list comprehensions. So Python is great in that, if I have some numbers and maybe I want to square each number and multiply it by itself, I can write a loop to do that really easily. And these two stars is the raising to the second power, the squaring syntax in Python. And maybe we're going to put this into a new list. And we'll just do the same thing twice and print out our squared numbers. And I'm going to go ahead and run this code. And I'm going to navigate into the directory where this is organized. This is in part two. Make sure I'm looking at the right thing. And let's go ahead and run it. And lo and behold, our numbers are squared. 1, 2, 3, 4, 5, and so on, get turned into 1, 4, 9, 16, 25, 36. As cool as this is with what's called a list comprehension in Python, we can do this in less lines of code. So instead of this, and let's comment out these print statements, what we can do is this. I'm constructing a list. I'm telling Python what operation I want it to do for each item in the list. Let's do num second. And it's sort of like a compressed for loop. Right? So just like I would write a for loop, I write that here, and I'm kind of defining this variable here, but then I'm also using it here. And we're going to say, hey, for each of these numbers, square it and add that to this new list that we're going to create. And so we see in one really nice succinct line of code, we can do all sorts of stuff. And I can use a range, right? The same way we saw if I want to maybe just add some numbers to a range, or maybe I want to square numbers from a range, so I want to do it this way. Right, so this is really doing the same thing. We're just using a range to generate that initial list. This can be useful with strings as well. Maybe I have some fruits. And maybe I want to convert all of these to uppercase and make a new list. So again, the syntax here is square brackets to indicate we're kind of constructing a new list. And think of it as the beginning of a for loop, right? For our temporary variable name in some list or iterable. And then at the beginning of the list comprehension is the operation we want to perform on each item. And we're making a copy of each item and putting it into a new list, right? So we can see that we have this new modified list of fruits, and the original is still unchanged. Alex, yes, sir.
I don't know if I'm getting ahead of myself here, but if after the equal sign, can you put like curly brackets to make it a dictionary or parentheses to do this as a tuple?
No, I don't think so. I would have to check.
Okay, got it.
Yeah. But there are other functions you can use to pretty easily turn a list into a tuple or dictionary. So that's probably the way that I would do it. And then the last thing that I want to demo here is we can use some conditional logic in here that we should keep it pretty simple. You don't want to make your list comprehensions too complicated because they pretty quickly become difficult to debug. So for example, let's have some more numbers. Let's just have them be 1 through 10. So let's say I only want the numbers that are divisible by 3. Or actually, let's just do the even numbers. So I'm going to use the modulo operator to divide n by 2 and get whatever remainder we have, right? So n modulo 2 of 1 is, it's probably 1. It's 0 for 2 because it divides evenly into 2. It's 1 for 3 because there's a remainder of 1. It's 0 for 4 because 2 divides evenly into 4. Excuse me. It's 1 for 5, right? Because there's one remainder. So we're going to check if this modulo is 0. And if it is, it means that n divides evenly into 2. And so now we've got some nice conditional logic that we can use. And you can make this more complex, but you do want to try and keep this pretty simple. Sam, yes, sir.
And can you do a list comprehension on the original list? So like say instead of rename or making a new list called evens, you just use numbers again.
Um, Probably. I would recommend avoiding that. Um, there's very little cost to just making a new list. Mutating the one that already exists often ends up adding complication, but yep, that totally works fine, right? Because we're using the old one and then we're assigning those to here. So we're effectively creating a new list and just overwriting the old one with it. Yeah, good question.
Yeah, so just best practices.
Yeah, what you all will find, it's called mutation when you change the value of a variable. When we get deeper into JavaScript and there's this idea of functional programming where you try to avoid changing variables and there's advantages to just making copies of things or making new sets of things because it's sometimes easier to just have a new thing than keep track of have I changed this old thing correctly. So that's list comprehensions. It is super useful. It's a great utility tool. So it's really good to know about. Um, there are some other related things to list comprehensions we'll see in a minute. But before I dive into that, I want to talk about another kind of conditional logic in Python called a switch case or a sort of a match case. And what this is, it's kind of a different way of doing if else statements. Um, some of the advantages are we can add a default. We can do some pattern matching, though this is a bit more advanced. So I'm really just going to introduce the tool now. I'm not going to get too into the ins and outs of it. And the scenario here is, let's say we want to get some input from the user. And Python actually has a great function called input that will take input from the command line. So just to show what this code is doing, this is when I run this, this is actually going to print out that question I put in the input function to the command line. It's going to take what I type and return that value and assign it to this variable over here. And this is super useful. Right. And so we're going to be using this a lot more in the course. So now that I've done that, let's say I want to give the user different responses based on what language they say. I use this keyword match, as in match the different cases or scenarios that this value could be. I give it the thing I want to evaluate. I'm going to go ahead and lowercase this so I don't have to worry about if I'm typing in caps or not. And then I hit colon and we put our block in here. And so then we make what's called a case statement. So this is one case statement. And then this would be another. All right, and maybe let's do JS or not sure if it'll let me do an or here. Yeah, I don't think it likes that. So let's maybe do it like this. We'll actually keep this simple for now. We'll do it this way. And then here's my default case. And this underscore is really just a placeholder for anything. And so now if I type Python, we get that. If I type JavaScript, we get that, right? If I type JavaScript, we get that. And if I type anything else, we get they like a different language. So you can kind of go deeper with this. I think there's ways to do some additional matching, and I'm not sure off the top of my head how to kind of add or statements in there, but this is sort of like the basic scenario. Um, and there's not a huge difference between this and an if statement. These are kind of good when you don't need too much logic in here, right? We could make this if else statements and it would be very simple. When all you need this to do is like print or return something. then this is when it's useful. For example, let's say maybe we want to put this inside a function. And so maybe we kind of modify it a bit like this. And rather than printing things, we're going to have it return things. And so now what I could do is I could print the response from the user input, right? And now I kind of have like a very nice, clean function that does one job. And I could write this with if statements, but it'd be a bit more work. If I had a lot more logic in here, maybe I'd want to switch to an if statement. It's really a little bit of dealer's choice, which one you want to use. There's not one best practice. So it's good to know about, but again, it's perfectly fine to use if statements as your sort of bread and butter for conditional logic. So that's the match statement. Let's talk now about lambdas. And these are pretty cool. So these are like JavaScript arrow functions. It's a function, but it's a function for a very small, simple task. And really, it's a function that we pass as an argument to another function, right? So we talked about the idea of first class functions, meaning Python allows us to pass a function definition as an argument or parameter to another function, or assign a function definition to a variable. And a higher order function is a fancy term for a function that takes another function as an argument. So let's see what a lambda looks like. So I could write a normal everyday function to add 1 to a number. And it looked like this, right? And we go ahead and we run this. You know, we're going to add 1 to 3. We're going to get 4. Oh, we better comment that line out there. And let's try this one more time. We add 1 to 3. We get 4. Our classic everyday Python function that we know and love. To write this as a lambda, it would look like this. I use the special keyword lambda, which is a term that comes from math. And here's the argument that I'm passing in to this function. And then on the right side of the colon is what I'm doing with it. And then I'm taking this lambda function statement here, right? And assigning it to this variable. So now I can do add 1 and call my lambda function. So this is useful for working with lists and all sorts of stuff. In some ways, it's very similar to a list comprehension. Again, for example, let's say I have some foods. You know, I have pizza, maybe I have chicken, maybe I have fish. and maybe I just want to do something to all of these. Like maybe I want to uppercase the first letter or uppercase all of them. Well, then I can use a lambda. But to use it and to kind of get that, I would use a map statement. So map takes another function as an argument. It iterates through a list or something list-like, an iterable. It passes each item in the list into the function, and it creates a new list and adds each modified item to it. So for example, with my foods, let's bring that down here. Maybe I just want to uppercase all of my foods. So let's use Python's map function, right? And we're seeing here this term iterator and iteratables. And we can just write a little one-line lambda in here. And so let me make sure I have my syntax right here as well. I misspelled lambda. That ought to do it. So this map function takes two arguments. The first one is our lambda function, which is everything up to this comma here. And the second one is the list that we're going to loop through. And so in a lot of ways, it's similar to a list comprehension, right? It's sort of like, this is probably how Python implements a list comprehension under the hood, is with a lambda. But notice how what's returned is not a plain ordinary list. It's some sort of map object. This is getting a little into the weeds, but Python has this special kind of class called like an iterable. It also has a map class. So it sort of has classes for working and looping through things. And we need to do some additional conversion to turn this back into a list. Thankfully, Python actually has a method for this that makes this super easy. And that method is simply list. And now we have a list of uppercase foods. So again, this is really similar to a list comprehension, right? In addition to map, there's also filter. And we saw this yesterday. And filter also takes another function as an argument. And it takes a list as an argument. And it iterates through the list. It passes each item into the function, which has to return true or false. And then if it returns true, the item is added to a new list. If it returns false, it's filtered out. Right? So maybe we have to go back to the example of numbers. I've got some numbers, and let's just get the numbers divisible by 3. And this is very similar to what we did with a list comprehension before. And we're going to do filter, and we're going to create a lambda, and we'll just use X as our little placeholder here. And we'll check if when we divide X by 3, if there's no remainder. and we'll tell it what list we're working with here.
Yeah, 2 equals, not 3.
Oh, thank you so much. Those are my JavaScript instincts kicking in.
Yeah, same here.
And in fact, since we know we have to convert this to a list from that sort of special map type, we might as well just do that now. And now if we print out divisible by 3, fingers crossed, we should see 3, 6, and 9. And indeed, there we go. So you can do a lot with list comprehensions. Map and filter, because they're so powerful, can be really useful on their own. And for those, you do need to specifically use a lambda. So I think that's really the use case. We will also see lambdas come up when we get to tests for this technique called monkey patching. So that's part of the goal of introducing them now, is so that we get familiar with them when we get to testing. So I've been covering a lot of ground here. Let me just pause and check in and see what questions folks have or what's on people's minds. All right, in that case, let's continue. There's a couple more things we're gonna look at here. I kind of put these a little out of order, but we're gonna look at this cool function called zip, and we're gonna look at a nice sorting function. And that's gonna really cover the bulk of our additional sort of like list and dictionary manipulation tools. So for sorting, and let me comment this out. Let's say I have a list of people, and this list is a list of dictionaries. And I'm just going to keep it really simple for now, just in the interests of time. So we're just going to have, let's actually add name and let's add age. And we're just going to have Alice and Bob and Carol. And note how if we look at alphabetical order, we go A, B, C, right? But if we look at number order, we're going big to small. So they go in opposite directions. So we're going to be able to use this sort tool to see a couple different examples. So let's go ahead and let's sort this list. So we need to tell this sort function what dictionary key to look for. And then it's going to use a lambda to do basically a comparison operation. So let's do key equals and what we're doing here is we're using a lambda to say, hey, grab each of these dictionary items, get the age, and return the age. And so that way, sort for the key that it uses to sort these by gets one specific value, right? The age value. So we're basically using the lambda to grab the bit that we want to sort by from each dictionary, because Python doesn't know what we want to sort by or how to grab it. This could be a super nested dictionary, so we have to tell it. And let's just assign this to a variable, and let's go ahead and print this out. And let me go ahead and first off, I've got something commented out there, and it looks like I may have a typo here. I think the issue may be, I think I got confused with the thing that's really easy to get confused by, which is pass by reference or pass by value. Let's print out our list of people after we've sorted it. So here we go, right? So the error I made is a really easy error to make. So many of these methods return a new list or a new array. It sort of makes sense that for sorting, we would want to sort in place is what it's called, especially since because it's a list of dictionaries and these are complex data types, we're probably dealing with pass by reference here. So sort does not return a new list. It sorts the original list in place. And so we see here that the original order was Alice, Bob, Carol, but now the order is Carol, Bob, Alice, right? We can also tell sort to reverse, and we'll kind of get back to the original order, right? So it sorted it by age and then it reversed it. And then of course, if we wanted to sort rather by age, but by name, we could do that. And right now we're Alice, Bob, Carol, ABC. So let's sort by name, but let's reverse it and we should get CBA. And let's see if that works. And there we go. We've reversed it again, right? So sort is super powerful and is a great tool in the toolbox. Tom, yes, sir.
How does sort react when you have the values instead of an actual value? It's like a list or another data container. Would you have to actually navigate into that to determine how to sort that value, or does it just determine automatically?
You mean if instead of a dictionary, this was another list or it had more layers or something like that?
Yeah, more layers. Like if
Yeah.
the people had dictionaries of lists, for
Mm-hmm.
example.
Mm-hmm. Yeah. Great question. So let's do a quick little experiment. So now we have this nested property of a list, right? And I want to look at the second element in the list in foo, and I want to sort based on that. So now I'm just going to change my lambda function, and instead of grabbing name, let's grab foo, and let's grab the second item in that list, and let's not do it in reverse. So this is the cool thing about the lambda function, right? I can do whatever I want in here. So no matter how complex my data structure is, I can grab what I want. And this is actually a great example of the power of a lambda in this kind of situation. And it looks like I just have a missing comma. Let's try this one more time. And in fact, the error message reminded me, did I forget a comma? And there we go. And now we're sorted again. Yeah, great question. Alex, yes, sir. And then I do want to move on to make sure that we cover the stuff we need to.
What's that key doing when you say key equals lambda?
Yeah, basically, we need to tell, let's actually hover over sort and see what it says. So if we just have a list of like strings or numbers, we might not need to set that key argument at all. And key is a named argument, by the way, or a keyword argument, like when we were learning about the different kinds of function parameters. But if we do it, then what the list does is it uses the lambda that we give it and executes that and uses it to sort. Basically, if we want to have custom control over how we sort, we need to pass into this key argument a lambda function. And then sort will use the value it gets from this lambda to do the sorting. So I think the way to think about it is sort needs to know how we want to sort the list. Do I want to look at this property, this property, this property, right? And we need to be able to tell sort how. And we do that with a lambda function that will take in each item and return the thing sort will use to sort it. And we pass this lambda function in as an argument, and the name of this argument on the sort function is key.
Okay, so do we have two arguments in this lambda function? Key as an argument, and then also the k after lambda. Is that an argument as well?
No, but I see what you're saying, and I think that's the tricky part about lambdas. Like, let's take this one, for example. So when you define a lambda function, it looks a little weird, right? And this is all one lambda function. And we're saying make a lambda. We're going to pass in an argument that we're going to name k, or I can name it x. It doesn't matter. X is going to have a property named foo, right? So X better be a dictionary or Python will throw an error. And then that dictionary, and then foo better be a list and have a second thing in it. And that's what we're going to grab. And that's what we return. And so I could pass in that lambda function as an argument like this. So the syntax does get a little dense here with lambdas, but hopefully that helps illustrate it a little bit. Let's look at one more thing for working with and manipulating lists, and then let's take a short break. And let me just go ahead and comment out our print statements. All right, and what we're going to look at now is zip. And zip is awesome. And zip is for combining lists. So let's say I have maybe some numbers and some letters. And let's say I want to put these two things together, and I kind of know that they should be connected. Maybe it looks like this. So I can use zip to combine some lists together. And the function name is just zip, and it's built into Python. And my first argument is going to be the list of numbers. The second is the letters. And if we take a look at the nice VS Code documentation pop up, we're going to get some tuples. It's going to be wrapped in some sort of iteratable. And we're going to see that these numbers and letters get combined into a list of tuples. So let's go ahead and print this. We're going to see that there is, I think, one more step involved, just like with map and filter. So we see that this returns something called a zip object. And if we look at its type in Python, and this, by the way, is sort of a shorthand for its memory address, which is just good to know. It's not relevant, but it's useful. We see it's of a class zip. And just like with map, we can turn this back into a list because it's sort of an iteratable, something that is designed to be looped over and that we can easily turn into a list. And when we do that, we see what we get is these pairs of tuples inside a list that have combined these two things together. Right? So if you run into a scenario where this is what you need, zip is super useful and easy to use. So let's go ahead and pause here. Why don't we take 5, and then when we come back, we'll look at exception handling and file handling. Sound good? All right, awesome, guys. Thank you very much. And let's take a break and we'll reconvene in 5 minutes. All right, so we talked through Lambda functions, we talked through map and filter, sorting, and zip, all really cool ways to manipulate and work with lists. Now we're going to switch gears a little bit, and we're going to be looking at dealing with error handling with try and accept. And we're going to be looking at some exporting and importing and working with files. So let's dive on in. And let me go ahead and do a little commenting out here. And let's talk about try and accept. So again, the goal right now is I just want to give an overview of these tools. I'm not going to go too deep into it. There are a lot of ways to use it. Just to build an example here, let's say we have some numbers. And I've made some sort of typo. And B was meant to be a number, right? These variables are maybe coming from user input, maybe from somewhere else in my code. We're going to do some adding of them together. And if I go ahead and I do result equals A plus B, and then let's just print a result. When I run my code, let's see what happens. We get an error, right? It says type error, unsupported types for addition. We can't add an integer to a string. So, when you write code, sometimes you want the error to happen. When you're writing a program from scratch for the first time, I think getting errors sooner is good because it gives you feedback. In a lot of ways, the error handling with try and accept that we're going to implement now, I think is good to implement once you've gotten your program working. Once you've gotten your program working, try and accept, let us gracefully handle errors. So this is called exception handling, and it's a universal concept in programming. And this lets us gracefully handle errors. And what does that mean? Well, exception means something that we didn't expect to happen, and it's an exception to the rule, right? An error, a bug, something that breaks our code. And so exception handling means making it so our program doesn't stop running when something goes wrong. And there are lots of ways to do exception handling. Again, get it working first, then add error handling. Well, let's see try and accept in action. So this is a problematic code where we're dealing with user input. We can never trust user input, right? Who knows what the user might type in, especially if it's a form coming from a website. So I'm going to wrap the code that might throw an error in what's called a try except block. And Python will try to do this, but if something goes wrong and it throws an error, our code will handle or catch that error. It's called raising an exception. And there's a lot of different kinds of exceptions. We've seen, in fact, this is a specific kind of exception or error. It's a type error that we could raise ourselves if we want. And we're just going to write a simple message to the user. really for the programmer. Not that useful, but good to see. Right, and so now let's put print result here. Let's run our code and let's see what happens. And let me go ahead and clear this and run this one more time because I think we had a couple of things happening. So interesting. We have a couple things happening here actually. We still see the original type error, but we also raise another error. And so I think what I was missing here is because this is throwing a specific kind of error, we may have to handle that specific kind of exception. So I may have gone a little lost in the sauce here. So let's see if we can set this one right. And to be totally honest, this is always where I struggle a little bit in remembering the syntax for exceptions. So I am actually going to get a little bit of help from the internet here because I think I know what's wrong. Right? I'm just not quite remembering how to do it. And in fact, this is kind of what I was looking for. So I need to say the specific kind of error I think that we want to handle. And we can give it an alias here. So, and I might just look at one more resource because a good rule of thumb is like, once you realize, hey, I don't understand something as well as I thought, let's kind of keep digging. I was hoping to maybe have an exception to catch any kind of error. And let's see if that's possible. Or if I'm maybe getting confused with different languages. And the issue here may just be, maybe I didn't add the as statement here. So let's play around with this a little bit and we can try a couple different variations on the theme. So we've still got these two errors coming up, right? If I comment out the exception that I raise. So here was the scenario that I was hoping to originally show, and I just got a little lost in the sauce here. And this is a better example of how exception handling lets us fail gracefully. I have this try block, right? We saw what went wrong, this type error. And then in the except block, it catches the exception. And we can do a lot with it. With this E object, for instance, we could print it. There's usually, I think, a message property, but let's just print E and see what's in there. And we do indeed see the message that's in the error. And in fact, we could have different blocks for handling different types of exceptions. So here I've got two except blocks. And this one's going to get triggered first because it's looking for a type error, which is specifically the kind of error that we ran into here. And let's go ahead and run this. And we see this none printed out here. And if I have a different kind of error, like maybe, in fact, let's just raise an exception here, and we'll call it my exception I created. Let's see which one of these messages gets triggered. Oh, and let me comment out this line because that's still throwing the original error. And now we see that depending on the kind of error that gets raised, different except blocks get triggered, right? So this is me manually raising an exception. So depending on the kind of error, we can handle it in different ways. You can do a couple other things with try except blocks. Like you can explicitly handle success with an else block. Right? So if we don't have any errors and everything goes well, the else block will get fired. And let's change this to be result equals A plus C. So we add two numbers together correctly that don't throw an error. And we saw that the else block does not fire if we do throw an error. And we can also add finally. So else is for success. And finally is for all the time. So if I run this code again, we see that finally message no matter what. And if indeed we throw it an error, we still see the finally, but we only see the else on success. So this is actually pretty advanced. I know this looks like there might not be that much going on, but when you're writing code, by far the easiest way to do it is get it working. Don't worry about exceptions till the code works. Then protect the important bits of the code and keep the exception handling simple to start with. Because as you saw, it's a little easy to get lost in the sauce there. So let me just pause here and see if folks have any questions sort of about exception handling. And I think then we'll move on and we'll look at sort of modules and importing and file handling. Rick, yes, sir.
Yeah, just a real quick comment. When it comes to exceptions, you gotta, for me, I had to pretend like I was the user. Like, how am I gonna accidentally break this? And that's how I modeled my exceptions.
Yeah, I think that's a good way to come up with the kind of exceptions to handle. The one thing I want to reiterate for folks is if you do exception handling before you're sure that your code works, you don't get the errors that you need to see to debug effectively.
Oh, no, I agree.
Yeah, totally. But yeah, I agree. Putting yourself in the mind of the user is absolutely the way to go. Let's go ahead. Let's actually take 5. And then we can pick it up with modules and importing and working with files and the file system. Yeah, I think, well, let's see. Do you all want to keep rolling or do you want to take a short break? I know we did take a short break. I just figure it's the afternoon. So I just want to check in with folks. If folks are good to push, I'm good to push. All right, let's do it. Give me just 1 second here, actually. All right, let me just pause things for a bit. I think this is actually kind of a good pause moment to wrap this video up, and next one we'll pick up in just a moment and we'll dive into modules and exporting and files in the file system.